Welcome to tonight's video on the review of trigonometry. Today we're going to start with angles and radian measure. Remember, whenever we have a letter, the Greek letter theta is commonly used to represent an angle at its measure. Positive angles are measured in a counterclockwise direction, right? Because if you go like this and you say that would be 100 degrees, that's positive. A negative angle would be measured in a clockwise direction. So if you're going like this and you want to say that's negative 60 degrees, the rotation is in a clockwise direction. An arrow is drawn in an angle to represent the direction that the angle is revolved. Yes. There are three parts to an angle. So if you draw an angle, there are three parts to the angle. The first one, this part right here, this is the initial side. It's where they both start. So the initial side is where the angle starts. Then it's rotated, and the side that rotates is what's called the terminal side. All right, the terminal side is what rotates. And where they meet here is what's called the vertex. So those are the three parts of an angle. An angle is drawn in standard position if the initial side lies on the positive x-axis and the vertex is at the origin, otherwise known as 0, 0. So basically, if you have a coordinate plane, right, and the initial side is here, the vertex is at 0, 0, that angle is in standard position. Yep. All right, a quadrantal angle is an angle whose terminal side lies on an axis. So any angle in standard position that rotates to an axis, like for example 270 degrees, right? That is a quadrantal angle. So drawing the following angles in standard position, and remember, key thing is the quadrants. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So if we start here at the x-axis, 135 degrees is going to go past the first quadrant into the second. So we'll say that's 135 degrees. Negative 280 So if we start at 0, this is negative 90, 180, 270. So negative 280 would go into the first quadrant, because negative means you go reverse. 535 degrees. Remember, you start here and you go 360, 360. Plus 90 is 450. Plus 90 is 540. So basically it's going to go almost there, but not quite. So it's going to end up in the third quadrant. That is 540 degrees. All right, radian measure of an angle. How is radian measure developed from the unit circle? Well, remember if you have a circle, right, and you have a central angle here, that's theta, and you have the radius, which is r, that all central angles intercept an arc on the circle, which we'll call S. So radian measure is just the arc length over the radius. So knowing that 360 degrees equals one circle in degrees, well, in radians, it would be the arc length. Well, the arc length of a full circle is the circumference, which you can cancel the r's, and you get 2 pi in radians. Notice if it's in degrees, you'll have a degree sign. If it's in radians, you don't have anything. So that's why it's important to put a degree sign if you want it in degrees. So that means 360 degrees is equal to 2 pi in radians. So if you wanted to convert an angle from degrees to radians, if you divide by 360, that means 1 degree is equal to pi over 180 in radians. So to convert from degrees to radians, you multiply by pi over 180. If you want to convert from radians to degrees, you take that same equation and now you divide by 2 pi. So that means 1 radian is equal to 180 over pi degrees. So basically, to go from radians to degrees, you multiply by 180 over pi degrees. So those are your conversion factors. So to go from degrees to radians here, you have 225 degrees times pi over 180. So 45 goes into 180 4 times, goes into 225 5 times, so it becomes 5 pi over 4. Negative 45 degrees times pi over 180. Well, 45 goes into itself once. It goes into 180 4 times, so it's negative pi over 4. And 240 times pi over 180. Well, 60 goes into 180 3 times, goes into 240 4 times, so it becomes 4 pi over 3. You will always leave the radian measures in exact values unless it tells you to use your calculator. Converting radians to degrees, negative pi over 2 times 180 over pi. So that means the pi's cancel. 2 goes into 180 90 times, so this is negative 90 degrees. 7 pi over 6 times 180 over pi. 6 goes into 180 30 times, pi is cancel. 7 times 30 is 210 degrees. 3 pi over 2. So 90 times 3 is 270. All right, so that's conversion. So now coterminal angles. Remember, coterminal angles are basically angles that have the same terminal side, but are rotated differently. In order to go from, so for example, if we said we had an angle that's 60 degrees, a coterminal angle, it would look the same. You could go the negative direction and say it's negative 300, right? Or you could add a full circle and go 360 plus 60, so also 420 degrees would be coterminal. So if it's measured in degrees, all the coterminal angles of theta, you basically can get by going theta plus 360 degrees k, meaning how many times you rotate it, whether you go in a positive direction or a negative. So you either add or subtract 360. If it's in radians, you either add or subtract 2 pi, because 2 pi is 360 degrees. To find a positive coterminal angle either between 0 and 2 pi, or 0 and 360, so if it's in degrees, you're going to keep it in degrees. So negative 210 plus 360 is 150 degrees. This should be a pi. So 15 pi over 4 minus 2 pi. So 15 pi over 4 minus 8 pi over 4 gives us 7 pi over 4, and that's between 0 and 2 pi. 495 degrees minus 360, that gives you 135 degrees. So those are the positive coterminal angles between either 0 and 360 or 0 and 2 pi. So using the radian measure, write the formula for arc length. Well, remember, radian measure is equal to S over R. Remember, S is the arc length, so theta is the central angle. S is the arc length, and R is the radius. So if you manipulate by multiplying by R, you get S equals R times theta, right? So basically, to find arc length, you take the radius times the angle. Now for the area of the sector of a circle, well, remember, if you have a circle, right, the area is 2 pi r, sorry, not 2 pi r squared, it's just pi r squared. The area is pi r squared. Now, if you're just talking about part of a circle, you want to know how much the angle is, right? To find the area of part or of sector, you want to know how much, what fractional part of the circle that is. So you would take the angle and divide it by 2 pi times pi r squared, right? Because you're taking the area, basically you're figuring out what fractional part of the circle it is, and then you times it by pi r squared. Well, notice in this formula the pi's will cancel, so the area of a sector is the angle divided by 2 times the radius squared. So, what's an important thing to remember about these formulas? That theta is in radians, right? So if you're given an angle in degrees, you have to change it to radians. So here's some word problems. So the first one, you have a sprinkler, right? There's your sprinkler. And it's set to spray water a distance of 25 feet. So it goes out 25 feet, and then it rotates through an angle of 120 degrees, right? That 25 feet, it's 120 degrees. And you want to know, like, what is the area of this that it sprays, right? What is that area? So you're finding the area of a sector, but remember first, you want to figure out what 120 degrees is in radians. So you multiply by pi over 180, and you get, well, 60 goes into both. 60 goes into 120 twice, 183 times. So 2 pi over 3. So the arc length, or sorry, the area of the sector is 2 pi over 3 over 2 pi, because you want to know, like, what fractional part of the circle is that. All right, so you want to know what fractional part of the circle is. So the angle is 2 pi over 3 divided by 2 pi times the radius squared, which is 25. Well, 2 pi over 3 times the reciprocal of 2 pi. Notice it gives you 1/3 times 25 squared, which is 625. So 1/3 times 625 is so if we go 1/3 times 25 squared, we get 208.33. And now it tells us to find the area of the region. We'll do 3 decimal places. So we'll go 208.333. And that would be square feet, because it's area. So we would say the area the sprinkler covers is 208.333 square feet. There you go. So the next one is a similar type of problem in that it talks about a car's windshield wiper. And so notice on a car, you have a windshield wiper, and the windshield wiper has like a plastic part, and then the wiper will stick out of it, and this is the part that will wipe the water off your car. So if you notice when you do the windshield wiper, it rotates this way, it rotates that way, and this part, so when you get it, it's kind of clean, just only in this part, right? Like the bottom part of your windshield still has some water on it. All right, so basically the windshield wiper rotates. If you think of this here, it rotates 125 degrees, which in radians, if we multiply by pi over 180, we could, 25 goes into 125 5 times, 25 goes into 180, it doesn't, I believe. So actually we'll do 5. So 5 goes in 36, 5 goes into 125, 25, so it's 25 over 36. So it's 25 pi over 36. That's your angle in radians. So what we have to do here is think about it in terms of the whole windshield here, right? So there's going to be, actually, let's start from there. So there's going to be draw this picture again. So if you start from here, it's going to rotate 125 degrees. So it's basically going to go around like this. And then this part will also leave something like that. So what you know is that the wiper mechanism has a total length of 25, but this part is only 14, which means this part is 11. So what you're going to do is you're going to find the area of the whole sector, which includes, so the area of the whole sector would be this whole part, which includes the part that's not being cleaned as well. And it's going to be minus the area of the sector not cleaned. So the sector that's not cleaned is this part right here, right? So if you take the whole thing and subtract this, that'll give you the part that's being cleaned. So the angle for both of them is 25 pi over 36, but for one of them, the radius, so we have 25 pi over 36 divided by 2 pi times 25 squared, because that's the radius for the whole circle, minus 25 pi over 36 times, and now the radius is just 11. And that'll give us our area. So 25 pi over 36 times 1 over 2 pi. Well, the pi's cancel, so that gives us 25 over 72. So 25 over 72 times 625. So we can type this all on our calculator. So we can go 25 divided by 72 times 625 minus, and we'll put this, so we can do a fraction, alpha y equals 25 over 72 times 121, which is 11 squared. So we have this part minus the other part, and that gives us 175. So basically, in square inches. So the area covered by the wiper is 175 square inches. That's the area that's covered right here. Right? If you take away the whole thing minus the part that's not covered. All right, that concludes our video. Hopefully you're able to do the WebAssign from this, and if not, please ask some questions during class or iBlock. All right, have a good weekend.